How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, I'm going to begin a new portion of the environment. We're going to be focusing on this part of the network right here. And what you and I are going to go do is a little bit of network discovery. So basically what we have been tasked doing is a network assessment. And I've done dozens of these over my career. So the customer has, we've got a customer. They are we'll go with financial customer. They work in the finance industry, bank, loan processing center, or whatever you want to throw at them. And they are a organization of multiple locations, and we have been tasked with doing an assessment. An assessment is multifaceted in many cases. An assessment is going to be a combination of multiple things. An inventory of all the hardware that they have, what's connected to who and how, and the current state of the network. So doing an inventory sometimes can be easy. You just log into whatever the network monitoring tool is and download a PDF or do a CSV export of SolarWinds. That's the easy button way of doing it. A lot of organizations that I work with, especially on the smaller side, and I'll say less than 1,000 users, less than 25 sites. You don't always have a network monitoring tool, or if they do, it is not a SolarWinds. It's they might have some sort of third-party tool that's a Linux variation of something, and all it does is a ping to make sure the device is responding. It's not everything is a SolarWinds. Not everybody has a top of the line monitoring tool like a SolarWinds or a PRTG or anything like that. So, and I'm sure there's others out there. I'm just not familiar with anything other than SolarWinds and PRTG. So there's MRTG out there as well, but that's again not as good as PRTG or SolarWinds. So what we're going to do in this video is we are going to do some discovery. So you might say, well, how do you map out a network? What do you do? So if you can get the inventory, great. But normally the way I go about doing it is I will try to grab an inventory, and if I can get an inventory from some system that'll produce a CSV file or a PDF output of something, awesome. I will take what I can get. That usually isn't the case though. So what I'm going to show you is how do you do an inventory and do a discovery at the exact same time. So the way that I've gone about it multiple times is I will go through and do a basic network discovery. I will log into a device and then I will do a show CDP neighbors. Hoping the CDP is enabled. It isn't always available, and if it is, great. If it is not, I will reach out to the customer and be like, hey, do you mind if I enable CDP to help me discover? And I think I've only had to do that 2 or 3 times in my career. Most people leave CDP turned on. They don't turn it off. So we're going to go through and we're going to, even though you have a topology, right? Even though I've already mapped it out for you and the hard work is already technically done, I am going to show you guys how I build one from scratch. The process isn't difficult. It's just a matter of figuring out who's connected to who and how. And then once you have, layer 1 is actually very, very easy in most cases. All you have to do is CDP, or LLDP, Link Local Discovery Protocol, and you'll just naturally find other devices that you're connected to, and then you'll be able to build a network map that way. I've done this more times than I care to count, and whether I'm doing an assessment or I'm been brought in onto a project to do a upgrade, migration, whatever the case might be, the first thing that I'm going to do before I do anything is I'm going to get a lay of the current land. Not LAN, local area network. I'm literally going to try to get a lay of the land and understand what's going on. And what's that equipment doing? So once I do layer 1, I will work my way to layer 2. So I'll understand where the VLANs sit, where the trunks sit, where the ether channels sit, what spanning tree looks like, where's the root bridge, where's the root bridge for specific VLANs. And then once I understand layer 2, then I will begin to dive into layer 3, and I will build logical layer 3 maps. Like, okay, this is where OSPF lives, this is where BGP lives, so on and so forth. So that by the time I'm done, I have both a physical layout of their environment. I know how everything is connected to each other. Then I have a layer 2 breakdown. I know where all the VLANs sit. I know where, at least I have a pretty solid picture of how layer 2 is built. I know where all the layer 2 information is, trunks, VLANs, SPIs, all that good stuff, ether channel, spanning tree, root bridge, all of that information. And then I will then dive into layer 3. I'll understand how the routing component works together, where the static routes are, what path do we take to get to the internet, all those things I will map out. And by doing that, I will be able to build a very clear picture of what they have. I care about layer 1, layer 2, and layer 3. The physical, the layer 2, and the routing. So if I understand how all of that is put together, I can then put together a proposal and say, okay, you've got this hardware here, you've got this hardware there, we're on this version of code, that's part of it too, and you'll learn that as you go along, is I will be building a spreadsheet as I am mapping the network out, and I will be noting, okay, this equipment is here. So it might not be a lot of equipment, but it's important to build both an inventory and a diagram at the same time. So if you're doing both at the same time, by the time you're done doing your discovery, you should be able to produce some sort of documentation. And then that documentation is going to be diagrams, layer 1, 2, and 3. And then from there, once you've taken a snapshot of what they've got, then you'll also know what version of code they're running. Do they need to upgrade their code? Are they, what is their licensing level? Are they licensed? Then you can go check, do they have SmartNet enabled on their hardware in case there's an issue? You'll have all this information available to you so that you can circle back to the customer and be like, okay, this is what I have. You'll be able to produce information for them to view. And once you've done your initial discovery, now it's time for you to interpret what you've seen. And along the way, you're going to see that anyway. You're going to see who's connected to who and how, what the routing looks like, what the layer 2 is. I can tell you, out of all the assessments I've done, I'd say probably 50% of them, or thereabouts, a lot of the networking issues that I found are just poor configuration. People not leveraging the capabilities that they could. And it's not to make fun of anyone, it's just the reality of the situation. I can't tell you how many networks I've walked into where the person that deployed the network really wasn't a network person. They might have done something else, but then they got handed the network and they were responsible for it. And so they did the best they could. So you might be handed a steaming pile of whatever you want to call it, and your job is to figure out what's in that mess. And to be honest with you, that is where real network engineering comes into play. You have to be able to extrapolate all the information that you've been able to discover and obtain, and then your job as the engineer, depending on the level of experience you have and your technical depth, you might come up with a different plan of action than I would. Now, I've come up with plenty of, hey, we need to go do this. I would recommend we go over here with this instead. Instead of doing things this way, we should do them this way instead. Here's a migration strategy for how you would do that. These are all things that you're going to have to think through when you're doing your discovery. So I just want to kind of paint that picture for you, just so you'd understand kind of how I've done things in the past and the success I've had in doing those type of things. So what I'm going to go do is I have a secure CRT here, and what we're going to do is we're going to log into these switches, and we are going to basically map out the environment. So I'm going to show you how I go about doing that. It's going to take a little bit of time. It won't be bang, 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 but we will have I've got a topology already built, so it's going to be pretty easy for you guys at home to follow along. But the point being here is we needed something that we could leverage to show that how that would work. So I'm going to go ahead and log into this guy. Let me go ahead and get out of the way while I'm here. I'm going to, oops, let me drop the volume on that. So I'm going to come up here and I'm going to type in host name, or actually before I do that, let's do a show CDP neighbors. Now CDP is a pretty cool capability. You have show CDP neighbors. CDP stands for Cisco Discovery Protocol, and it's doing exactly what the name implies. You are discovering other Cisco devices leveraging CDP. Now there is a show LLDP neighbors as well, but LLDP is not enabled. Link local discovery protocol is another capability, but that's the open source version of it. So for right now, I'm just going to type in LLDP and it should be run. Okay. So I'm going to go ahead and say show LLDP neighbors. So right now we don't have anything running. Or no other devices are running LLDP. We'll do that here in a minute, and we're going to take a look at both of them. They have very similar outputs and work very similarly to each other. So I'm going to, on switch 1, I'm going to come over here and I'm going to go, host name is going to be switch 1. And I'm going to save that config. Now what I'm going to go do is I'm going to go over to switch 2, which is directly connected to switch 1. I'm going to do a show CDP neighbors. And after 60 seconds, or it's going to take some time, but CDP has a 1 minute hello and a 3 minute hold time. So if you notice right here on gig 01, right, we were learning switch, the device ID, because that's the host name. But because we changed the host name to switch 1, on that same interface, we're learning switch 1. And if you notice the timeout value, this entry right here will eventually go, age out. So, and the reason why it's going to age out is because this device ID is no longer being broadcasted from switch 1. It's using switch 1 here. So when I get down to 120 seconds, it's going to restart itself. Gig 00 and gig 01 are both going to restart themselves. So I'm at 120, so it's that. So they're quickly starting to go down. And once the whole time gets down to the 120 mark, as long as CDP is still working, you'll see it jump back up to like 180. And here, this is a 179. It was a 134 before. And as you can see, it's going to eventually, those two switch entries, this one and this one, will eventually age out because their timer values are starting to drop. Okay, so that's how you would do that. So now I'm going to go up here and type in LLDP run, type out a global config. I'm going to come over here to switch 1, and I'm going to do show LLDP neighbor. And now we can see switch. So we know it's working. Let's go back to switch 2. Let's go to global config. Host name is going to be switch 2. Go back over here to switch 1. Hit the up arrow. And notice how switch 2, it automatically does it. The cool thing about this one is you don't have to wait. It automatically will trigger it, whereas CDP is a little bit more finicky in that respect. So there's that. So let me go on switch 1. I'm going to type in CDP, and I have a couple of options here. By default, this is what advertise v2 is what ends up happening. If I do show run all pipe includes CDP, right now it runs advertise version 2, which includes a whole bunch of information like the speed, the duplex, the native VLAN, the trunking information, all of the iOS information, so on and so forth. The timer is set at 60 seconds, which means a hello. The hold time is 180, so every 1 minute it sends out a hello, and if it doesn't get a response in 60 seconds, the hold time starts to kick in until 180 drops to 0, like it is right. Do show CDP neighbor, just like that. Switch 1, switch is now gone, and we just have switch 1 replacing it. So that's how that works. There are some TLVs, type length value add-ons here, but we're not really going to be using that. So if I wanted to, I could type in no CDP advertise version 2. Okay, now if I go to switch 2, right, nothing really changes from that output. I'm just going to wait for the the timers to time out. Now, the differentiator here is if you turn off advertisement of V2, which I don't recommend anybody do, what ends up happening is you just lose contextual information. So your timers don't time out. So let's take a look at what that would look like. So on switch 1, we are going to do a show CDP neighbors, right? We see switch 2. And if I do a show CDP neighbors detail and hit the enter key, I'm going to get a bunch of information about the entire device. So we're going to see the ID is switch, the address is it's a Cisco box, router switch IGMP. We are connected locally, gig 0/3 on switch 1. We're connecting to switch 4, even though you can't tell. So let me go ahead and just update these real quick, just so we have contextual awareness. Host name is going to be switch 3, do save. Switch 4, same thing. Just so we can tell who's doing what. So now, after a period of time, we should see on switch 1, once those timer values for gig 02 and gig 03 time out, we should start to see switch 3 and switch 4. So I'm going to pause real quick while that works. Okay, so on switch 1, we can see that switch 4 is attached to gig 0/3 and switch 3 is attached to gig 0/2. Perfect. That's exactly what we're looking for. Okay, now that we have that in place, the big thing that we're going to now be able to do is that it's going to give us contextual awareness. So what I'm going to do is on switch 1, I'm going to do a show CDP entry. So we have several options that we can look at, and we're going to say entry for the name of switch 2. And we can hit the enter key. So what it's going to tell us is a whole bunch of information. Let's scoot this up just so you guys can see everything. So we're learning this on 2 different interfaces. We can see it's switch 2, entry addresses. There's no IP addresses on the device yet, so that's why you don't see anything. The capabilities are router switch IGMP, and we are learning this on gig 0/1. The outgoing port is gig 0/1. The hold time is 143 seconds. The iOS version that it's running is this guy right here. And if you need to reach out to support, this is how you would get a hold of them. Advertisement version is 2. Okay. Now if I go over to switch 2, and I do a show CDP neighbors, we're going to see that, but I'm going to do entry for switch 1. And you notice how the information that I've been given is a little bit more contextually aware. So if we look here, we can see other information. We can see the advertisement version is 2, the BTP domain, the native VLAN, the duplex. But if we look at switch 1, we don't see any of that. So this is because if I do show CDP, oh, it didn't take it off. Or do I have it running here? Show CDP. CDP advertisement. Yeah, okay, so that's what I would expect. So there is information that is not being shared from switch 1 to switch 2. So because there's no advertisement, it doesn't know how to reinterpret it. So if I go back up here and type in CDP advertisement v2 and hit the enter key, I should start to get that information in. And it might there it goes. So it just took it a couple seconds for it to get an update. So you notice that on this interface here, we're getting all the additional interface information. If you're not advertising it and don't have it turned on, it won't know how to read it. So the bottom line here, folks, is just run version 2. There's no real benefit to running a version 1 unless you're on some really old version of iOS. Then it might not support version 2, but that was like 10, 15 years ago. So you have to assume at this point here everything's running version 2. So with that being said, we have that in place. So what I'm going to go do now that we have everything rolled out and everything is squared away, if I do a show CDP neighbors, I have switch 2, switch 2, switch 4, switch 3. So what I'm going to do, based off of what I'm seeing here, I'm going to scoot this guy over, and I really only need this much information, and I'm going to go ahead and scoot this guy over just a touch, and we're going to draw this map out right here. We're going to start on switch 1, and we're going to work ourselves all the way around to switch 4 and map this out. So I'm going to switch over to black. So first thing is first. I grab my pen, and so I'm going to grab this guy here. I'm going to say S1, and then I have on S1 I have, and so when you first look at this, you're not going to know how the network is laid out. So you're going to have you're going to see S4, you're going to see S2, S2, and S3. I'm using S instead of SW for simplicity. So actually, let me move this down here so that it's more centered. So we have that. So on here, the local interface here is going to be 0/3, and the remote port ID on switch 4 is going to be 0/0. That's how that's connected. Then over here on switch 2, we're going to use 0/1, and then over here is going to be 0/1, and that's going to be connected there. We're going to do 0/0 to 0/0, and that's how they're connected. And then we're going to have 0/2 is going to be connected to over here to 0/0. Now that we have that in play, I can then go to switch 2 and do the exact same thing. So let's go back to switch 2. Okay, and we're going to do a show CDP neighbors. And then I'm going to do the same thing here. So on S2, we're going to have S4, S1, S1, S3. And then here we're going to have 0/3 to 0/1. Then we're going to have 0/0 to 0/0, 0/1 to 0/1, and then 0/2 to 0/1. So that's how they're connected. Now, by doing this, you're able to see how these switches are all wired. You see the wiring. Now, let's go to the next one. Let's go to switch 3. And we're going to do a do show CDP neighbor. And same thing with 4. We're going to do show do right, do show CDP neighbor. Okay, I'm going to go back to 3, and we're going to say, okay, so 3, S3 connects to S1 and S2. So we're going to know that that's going to be 0/0 and 0/2, and then 0/1, 0/2 over here. Okay, and then S4 is the exact same process. So we're going to go back to here. We're going to have switch 4. We're going to have 0/0 to 0/3 and 0/1 to 0/3. So with this done, what we will be able to do now is, now we have the wiring set up, we can then start to kind of piece together how the architecture is put together. Because out of the gate, you're not going to know, right? You're not going to have a network diagram in front of you to validate against what you're discovering. So as you're discovering, you're trying to see in your mind's eye, how is this actually wired together? So based off of what I'm seeing here, how would I go about doing this? So let me draw it out over here. So I'm going to go back to this guy, but I'm going to go ahead and get out of the way real quick. I'm going to change this over to be white. So first things first, we know that switch 1 and switch 2 have more connections to 4 and 3 and than 3 and 4 have to 1 and 2. That would tell me, based off of this information right here, that switch 1 and switch 2 are north of me because there's more interfaces connected. So that means I'm going to come over here and I'm going to say switch 1, switch 2. And I'm going to say that if I'm on switch 1, I see switch 2, 0, 1 to 0, 1, 0, 0 to 0, 0. I'm going to say 0, 0. Actually, I usually put them in the middle. 0 slash 0, 0 slash 1 between switch 1 and switch 2. And then on switch 1, for switch 3, I'm going to say it's 0, 2 to 0, 0. So I'm going to say switch 3, and I'm going to put over here is going to be, this one here will be 0 slash 2 to 0 slash 0. And then over here on switch 4, I'm going to see this is 3, so I'm going to say 0 slash, whoops, let me move this over here just a little bit. I'm going to say 0 slash 2 and 0 slash 3. So this will go to here, this will go to here. And then I'll do the same thing on switch 2. For switch 2, I'll do 0 slash 2 and 0 slash 1. And this will go to here. And then on switch 2 to switch 4, we're going to have 0, 3 to 0, 1. So I'll do 0 slash 3 to, this is supposed to be 0 slash 0, and then 0 slash 1. So what I've done, and I'll just do dashes here for completeness. What I've done here is I've mapped out the network. It's not always this straightforward. You might have actual equal connections to each other, but by literally just drawing it out and trying to piece together how many interfaces are together, you can start to build out a diagram. You might not be correct in the direction that they're set up. They could be 1 and 2 could be logically south of 3 and 4. That's not really that relevant until you start getting into where SBIs sit. So if let's say, for example, you're not sure. Let's say you draw switch 1 and switch 2 south of switch 3 and switch 4. Okay, no harm, no foul. You're not hurting anything by having a slightly wrong network diagram interpretation. So what would end up happening is, if that's the case, when you're doing your layer 1 inspection, trying to find who's connected to who and how, that's essentially what you're going to discern from this. What you would do then is you would work your way up logically to layer 2. So, okay, VLAN IDs. I'm going to put VIDs for short. VIDs, where do the VLAN IDs exist? Okay, across the board. Where are your trunk links? Across the board. They should be in the same row of places. What about your port channels? Well, port channels are going to be a pretty good indication unless somebody went hog wild and did port channels everywhere. In most cases, you're going to do port channels on equipment that needs it. Unless you've got more than one device and you're doing some sort of stacking or chassis aggregation, then the port channels might not be a discernment. But what will be is when you move up the stack even further. And so even at layer 2, you checked out the VIDs, the trunk links, the port channels. What about the root bridge? Where's the root? The root should be logically north of everything, unless somebody just let spanning tree figure itself out and didn't care. So, and I've seen that too. I've seen the access layer switch, a very, very old 2950 or 2960 or 3550 switch is the root bridge in a very large switch environment with 6500s and 4500s, because they just didn't know any better. I literally was like, your root bridge is sitting on an access switch, right? And I was asked point blank, and I'll never forget this, what's the root bridge? This goes to my point where a systems guy, actually it was a systems lady, was a Linux engineer for years. She had been there so long that all the people that had built the network were gone. And they had never really, there was no documentation. They just were operating literally on a wing and a prayer, hoping that nothing would ever crash. So they had access to the equipment. They could log into it. And so literally what they would do is, like every month, or there was a period of time every so often that they would go in, they would do a show run And if they needed to make a change on the switches to change a VLAN or whatever the case might be, or put a port into a different VLAN, they would Google what to do, then do it, save the config, do a show run of the config, and then that would be their updated configuration, and that was their backup plan, which isn't necessarily bad. I know, you guys are like, wait, what? And then they did have hardware failures, and when they did, they would go out and just buy new hardware from wherever they could get it, and then they would retrofit the network. And that is how they got to where they are. So it wasn't a great environment, but it still was the case. Now, with that being said, the root bridge should be logically north of anything and sitting on what would be your gateway. And this is where you can make the determination, if you're not sure, is when you get to layer 3, is where are the SVIs, or interface VLANs, configured. Assuming that they're doing layer 3 switching. If they are doing router on a stick, then you'd have to, obviously that would be logically northbound, because routers don't normally do switching. Unless you were to put like the module into it, like a 4 or 8 port switch into the router. So in those cases, you can do that if you'd like, but in most cases, most customers run layer 3 switching. It's better all the way around. I'm going to show you router on a stick, but layer 3 switching is by far better. So if your SPI, if you can find SPIs, you have found the logical northbound, and so all you have to do in your diagram is flip the links. Is move that switch on top of the other ones, and you're in gravy train. That is how you can go along and figure out how the network is built, by doing a discovery process that way. And this can be expanded upon over and over and over again. So the cool thing is, you can use this technique over and over and over again to discover your networks and figure out how they're built. I've done this hundreds of times over my career, and I say that literally hundreds of times, because you've had to discover hundreds of locations and how they're put together. And I've had some customers that have 50, 60 locations, and I'm building out. I had a large, kind of a small to medium-sized retail customer about 6 months ago, where we were doing that exact same thing. We had 2 bigger locations. One was at like an HQ, an actual like brick and mortar location where people would go in the morning and do their job. But then they had a distribution center that had dedicated power and a couple of high-speed internet circuits. That was their data center. Their data center wasn't even on-prem. It was in another location, and it was kind of a mess. But my job was to go through and discover all of their entire environment. I was there was lots and lots of hours, and that was my job. And I went through. It took about a month and a half to fully discover the environment. So basically, Monday through Friday, from 9 in the morning until 5:30, 6 o'clock at night. That's literally all I did for 5-6 weeks straight. I had a bunch of documentation that I created, and I knew their environment really, really well. I could tell you what was going on where. Every once in a while, I'd have to reach out to the customer engineer and ask for ask questions, because he's the guy that put it in, and be like, hey, am I looking at this right? Am I interpreting this correctly? And I'd say 95, 96 times out of the 100 times that I talked to the guy, I was correct. There was only a handful of times like, no, this isn't quite right, and this is actually what's going on. Like, oh, okay, cool. So I don't ever claim to be perfect, but I do a pretty good job of getting the job done. So what's cool about that, though, is by the time I got done doing that, I was able to go through, and I had a bunch of documentation built. I knew who was connected to who and how. All that stuff was knocked out. So all I had to do then was take that, put my thoughts. It took a week or two, once I got done doing all of the discovery, to circle back and put it into a very clean Word doc, and put all the steps in there that I thought needed to be updated and changed, and optimizations, moves, add changes, deletes, things like that. And the goal is, for every one of the things that I thought would need to be changed, was supposed to be would generate an opportunity, meaning we would be able to spin a project out of that. I think that project generated, I don't know, 15 or 20 projects, or that one assessment did 15 or 20 projects across the board in multiple cases and stuff like that. And I ended up putting in, I think, 6 or 7 projects just on that customer alone that we worked through over the course of about a year. But that's kind of where I'm going with this. I started here and worked my way up to where I knew the environment. And you do that enough times over your career, you get really good at understanding how the good, the bad, the ugly, and just the bad wrong, and how that stuff gets put together. But it was my job at the time to do the interpretation, bring that back to the customer, because that's what we're getting paid for, right? That's my skill set. Like, okay, let me come in and take a look at it, and go do what it is that I got to go do. So I enjoyed the work because I was able to deliver something at the end of the day, and it's like I'm the one to put that together. So did they always go with what I said? No, not all the time. I'd say probably 70 to 80% of the time, whatever I suggested they would roll with, and then it was just trying to come up with budget in order to make that happen. So sometimes it would be I'd be the one doing it. Other times you'd have maybe it was wireless or security or something like that, and then other engineers would be brought in to handle that. I would give them knowledge transfer on what I'm seeing. They'd be like, okay, cool. We're going to go from there. So it was definitely leveraging CDP and LLDP to do that job are key capabilities in that respect. So, and then understanding how to interpret the diagram is what's going on. So you start off here, and then you end up over here, and you're able to understand how everything's put together, build a logical diagram out of it with multiple facets, layer 1, 2, and 3, and then once it's all put together, you're able to deliver that as an assessment plus an inventory. Which versions of code are being ran where, and then that in and of itself is a project, is just doing code upgrades. Some store you'd have to do work at night, so you'd come up with an upgrade schedule and all that type of stuff, and then do your upgrades. Sometimes it was the store manager would stay after hours, plug a USB stick into it. There were all kinds of things that we had to make happen in order to get the job done. But that was essentially what we ended up having to do. So that is where layer 2 protocols come into play. I'll talk about UDLD at a different point in time, but as you can see, that's where it really comes into play and how it operates. So that in and of itself is how layer 2 protocols are leveraged. That's at least how I use them and what you can do with them. With that being said, ladies and gentlemen, I hope that was informative for you, because that's one of those things where if you take your time to understand how the network is built, you're out of the gate. If you can deliver a diagram and some basic documentation that's going to hopefully benefit the customer, you're automatically bringing value to the table. That's one of those things where you've got to keep in the back of your mind what it is you're trying to do. So if you guys have any questions or comments, concerns, feedback, please drop that sucker into the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch you guys in the next video. Have a good one, everyone.